Welcome to lesson 3. I'm going to try and keep this fairly short because the actual problem is one of these where it shows you a division expression and then asks for the unit form and then for you to make an improper fraction, a mixed number, and then actually showing with the quote standard algorithm, what we call parent style, the kind of answer that you would get with this if you turn it into a division problem. Like I was saying, and like we looked at yesterday with the using measurements and seeing how if an inch is broken into eighths, you're actually dividing by 8, that kind of thing. So I'm going to do a few of these because here's what your homework problem looks like. It's about making 9 cupcakes and then going division expression, a unit form, fractions, mixed numbers, and then working out the math problem, showing your thinking in a drawing. So here's what we're looking at. I'm going to kind of go through and show you the example that they've provided, and then I'll probably cruise down to D and do D. So what we're looking at is here it's saying the division expression. 4 is divided by 3. So we read from left to right. And a way to look at that then is to say that 12 thirds divided by 3 is equal to 4 thirds. And how do they get this 12 idea? Well, you know that 12 comes from 4 times 3. That's one aspect of this. The improper fraction, 4 is up top. What is your divisor? Well, it's also your denominator because they both start with D, right? It's easy to remember. So your denominator is a 3 because you're dividing by 3. And it's asking how many times can you fit 3 into 4? Well, we know we can fit 1 3 into 4. And so here's our whole number, our 1 right here, 1, and what's left over? 1 out of 3. And here's what it looks like if you do it standard algorithm / parent style. You make your division shape, your house. This is saying 4 is what you're dividing. So it's really important to remember that this first number right here, this is what's being divided. This is what you're dividing it by. So this is what you're dividing by. This is what you're dividing. So we know that 3 fits into 4 one time. And then you say, okay, 1 times 3 is 3. What's the difference? It is a 1. So the 1 then comes up here and it becomes your numerator. Who's your divisor? Your divisor's 3. It becomes your denominator. And then they're going to show you how to check this. So like we've done in the past, it's like, if it's just simple and basic, if you're going, how many 5s can you fit into 10? We know 5 goes into 10 2 times. 2 times 5 is 10. What's the difference? It is nothing. So we know that to check this, if we multiply these two, we should get this. That's what they're showing you, is that they're multiplying 1 1/3 times 3. Right here, 1 1/3 times 3. The quotient times the divisor should get you the dividend. So they're saying here it's 3 times 1 1/3. So they're saying, oh, that's the same as repeated addition, right? Because it's multiplying. 1 1/3 plus 1 1/3 plus 1 1/3. 1, 2, 3. And then 1, 2, 3. So it becomes 3 and 3/3. We know 3/3 is also 1. So they get their 4. And that's what we were looking for our dividend was a 4. Remember that? Okay, this one seems like it's probably the toughest part of this right here, is the idea of 12 thirds being divided by 3 is the same as 4 thirds. So let's look at what that would look like. If you have 12 thirds and you're dividing it by 3, it's like 3 over 1. And so here's kind of a trick when you get further along in your education. When you're dividing by a fraction, you're actually going to flip this one and then multiply. So this one stays the same, 12 over 3. We change it to multiplication. We flip this upside down, 1 over 3. So that's going to be 12 times 1. which is 12. And then we're going to have 3 times 3, which is 9. And so when we go into this, we go 9 goes into 12 one time, right? 9 goes into 12 one time. And there's 3 ninths left over. And if there's 3 ninths left over, I know 3 can go into 9 and 3 can go into 3. I keep my whole number. 3 goes into 3 one time. 3 goes into 9 3 times. This answer right here, it matches this answer right here. And so when you work this, then that's just different ways of looking at what's happening through the same thing. So what they did is they were thinking, oh, 4 times 3 is 12. So let's see if that keeps going. Let's take a look here at the 7 divided by 4. And I'm going to skip that one first because it's kind of unique. So what we can do is we can look over here. This right here is the fraction version of it. And so here they've got 7 fourths. And let's cruise back up here to remember mixed numbers. So how many does it take to have a 4? According to this denominator, it takes 4 to have a whole. If you have 7, how many 4s can you get out of that? Well, only one of them. Because if you have 2 4s, you're at 8, right? And what's the difference between 4 and 7? Count up. 4, 5, 6, 7, 3. What's our denominator? It's still a 4. So we have here 1 and 3 fourths. And so when we look at this and we think about the other thing that they had done, if we're going to say how many fourths would that be? So we can have that line and we're saying fourths, F-O-U-R-T-H-S, divided by, what are we dividing by? They're saying halves divided by 2. We're saying fourths divided by 4 is equal to how many fourths? And so if you go 4 times 7, you know it's going to be 28, right? 28. And so if we have 28 fourths divided by 4, 28 divided by 4 is 7. And that's where this numerator comes in. Now let's go standard algorithm style and take a look at this. So let's look at the example that they gave us. So if we've got this division problem right here where it said 4 divided by 3, they made a division problem right here. Let's do the same thing. So I'm going to make that house. Here's that house. And what are we dividing? We have 7. We are dividing it by 4. 4 goes into 7 one time. 1 times 4 is 4. We find the difference, which is a 3. 4 doesn't fit into 3, so we're done, right? And this becomes the numerator. Our divisor becomes the denominator. 1 and 3 fourths. 1 and 3 fourths. And so when we go to do the check example, remember we're going to multiply the quotient by the divisor. So we can do repeated addition. 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths. So when we add this, 1 is coming together 4 times. 1 is being added to itself 4 times. And then we can count these 3, 6, 9, 12. That's 12 fourths. And remember, if it takes 4 to make a whole, 4 goes into 12 how many times? 4 times what is 12? It's a 3. So this becomes then 4 plus 3, which we also know happens to be a 7. So when we check this, this is what we got, and this is what we started with, because it was our dividend in our division sentence right there. So given that pattern, I'd like you to try this one. So if the baker made 9 cupcakes and each was a different type, 4 people wanted to share them equally. So how many cupcakes does each person get? So if you'd like to start with the drawing, you can kind of start with your cupcakes over here. Here's one of them. Here's 2. Here's 3. Here's 4. 5. 6. 7. 8. And 9 cupcakes. So there's 2 different ways you could look at it from that point. One thing that you could do would be to say, well, I'm going to cut each one of them into 4 equal pieces. Count how many pieces I've got all together, right? That would be like 9 times 4. Then you know how many pieces you've got, and then you can just take the pieces and give them to the people. Or you could think, I've got 9 cupcakes. So if I give each person one of them, right? So this one could go to person A, person B, person C, person D, person A, person B, person C, person D. Then you only have one left. Think about that. So how much cupcake did each person get? Think about that. This one you're going to probably break up into pieces, right? So here you're going to have your division expression. So you're going to have something divided by something else. And then your unit form is where you're going to think about what if you turned it into pieces? How many pieces total? What are you dividing it by? Fractions and mixed numbers. And then your standard algorithm, doing it parent style. So I highly recommend, if you need to go back in the video again, I can even scroll back to kind of show you as a reminder what was there. Do you remember where I did that when I was making the video? I came back to this problem. If you need to do that, that's where it is. So you can go back and forth. Thanks.